Hi everyone, welcome to our video on multiplying a scalar with a matrix. So a scalar, so the vocabulary is not written, a scalar is just a number that's in front of a matrix that will multiply every term. So it's almost like it distributes. And then your matrix is are the numbers that are inside a bracket, and it's like kind of like a table. So in this setup, or in this problem, they give us two matrices, and then they want us to do all sorts of scalar multiplication with it. And so the way that we'll do this is just let's rewrite it. So it tells us what A and B are. For number one, it's saying that 3A, so let's do equals 3, and then just rewrite the A as the actual matrix that they said, like that. And then from here, all we're going to do is just make sure that this 3 multiplies all the elements inside the matrix. Okay, so a little messy with the blue arrows, but it needs to multiply those 4 elements. And so we would have negative 12 in the top left, positive 6 in the top right, 3 times 3 is 9 in the bottom left, 3 times negative 7 is negative 21. Okay, so there we go. So it's pretty quick. So it's kind of like distributing. It's not technically distributing, but it is just making sure we multiply every part of the matrix. So for number 2, it also has A involved, so it's saying just rewrite it real quick first. So there's negative 5, and then just go ahead and rewrite your A down. And then from here, I'm not going to draw the arrows because it's a little messy, but I'm just going to think I need to multiply all of these by negative 5. So just be careful with the sign. So negative 5 times negative 4 is 20. Negative 5 times 2 would be negative 10. Negative 5 times positive 3 is negative 15. Negative 5 times 7. Oops, I didn't write it down right. Be careful of that too. Negative 7 down there. Sorry. So that's where a lot of matrix errors come from. Is just going too fast. So sorry about that. So negative 5 times negative 7 is positive 35. There we go. And if the matrix has only numerical elements, we can do it on a calculator. We can check. Now, the TI-84 and 80 or Inspire or any TI can do these. I'm going to use the free resource Desmos.com and go to the matrix just to show it here real quick. And let's do new matrix with A. And here's where we really have to make sure we're typing in everything right. Okay, so there it is. And with this operations, or with these operations, so the first one was just 3 times A. And there it is. So it can be quick. And just double check, 12, 6, yep, everything's there. And then we could double check like the negative 5, so I almost messed that one up. There it is, negative 5 times A, 20, negative 10, negative 15, positive 35. Okay, so you can double check it with a calculator pretty quickly. However, whenever they start to throw variables in, like letter B has variables in it, well, then again, usually calculators can't handle variables in a matrix menu. So at least the ones that I know about, maybe the Inspire, I'm not sure, can handle it. But let's still make sure that we could do it by hand regardless. Okay, so for number 3, it's now multiplying with B. So we'd have 7, and then again, just rewrite it. So you got your 2, 0, 3x, 1 minus 4y. All right, and then it does multiply every term just like it did in the previous 2 examples. So the 7 multiplies 2 to get 14. 7 multiplies 0 to get 0. 7 times 3x would be 21x. And then over here, let me actually use some colors. When this 7 multiplies, it is multiplying each of the terms as it would in a normal distribution problem. So just make sure to actually continue distributing. So 7 would times 1 to get 7. And then 7 times 4 would be 28. And then attach the y and make sure it's still minus in between. And let's box that up, and there we go. Okay, so that's the one thing we have to be careful of with some of these scalar multiplying a matrix. So just make sure it does multiply every part. All right, so number 4, negative 2 is hanging out. And then B, let's just make sure to write it. So 2, 0, 3x, 1 minus 4y. Well, like all negatives, we just have to be careful when we multiply. Just make sure that the sign is correct at the end. So negative 2 times positive 2 would be negative 4. Negative 2 times 0, so 0 is always good. That's 0. Negative 2 times 3x would be negative 6x. And then, just like the last one, make sure that negative 2 does multiply each of those coefficients there. So negative 2 times 1 is negative 2. Negative 2 times a negative 4 would change it to positive, and then 8y. And then that's as far as it goes. No other simplifying, all done. Okay, so that's that. Okay, so let's see the other types of variety that they might put. So here we've got two others where they involve both matrices. Well, same deal. So let me put equals, but maybe let me just go ahead and put it right underneath. So 8 and then a. I just want to make sure I'm copying a down correctly. So negative 4, 2. And then 3 and negative 7. So just making sure, yep. Okay, and then minus 2, so minus 2, like that. And then let's write down b, make sure to write that down correctly. It's 2, 0, 3x, and 1 minus 4y. There it is. Okay, so there's our setup. And then, well, we're going to distribute, or not distribute, we are going to multiply, but again, it is very much like distributing. So this 8 multiplies all 4 elements there. So we would have negative 32, positive 16, positive 24, and then 8 times 7 is 56, but it's still negative, so negative 56. Okay, so the 8 multiplied all of them. Maybe just quickly eyeball it, make sure all of them did get multiplied. Okay, and then here you have kind of two options. I'll show them in the different ways. Let's go ahead in this one. Let's just leave, I'm going to leave the minus as minus in between. And let's do only the positive 2, multiplying all of those inside there. Okay, and when we do that, so I'm leaving the minus for later. So positive 2 multiplies, and we have 2 times 2 is 4, 2 times 0 is 0, 2 times 3x is 6x, and then 2 times 1 minus 4y, remember, just multiply each of those, and we would have 2 minus 8y. There we go. Okay, so this involves back to subtracting matrices. Remember, when we subtract matrices, we are going to subtract the corresponding elements. So each of these are a 2 by 2 matrix. So what we'll do is set it, I'm going to set it up. Okay, so I've got my 4 spaces ready, and then we'll do negative 32 minus 4. And then we'll have 16 minus 0. And then we'll have 24 minus 6x. And then we'll have negative 56 minus, again, they're not shown, but it does have the implied parentheses. So it would be minus parentheses 2 minus 8y. Again, and be careful, I didn't really give myself the best room, but I think it works. And then now let's finish it off. Equal to the first element does simplify, it's negative 36. So does the second, it's 16. The bottom left element, that is as good as it gets. Those are not like terms, so we'll just rewrite them. And again, give yourself plenty of space so we know which elements are simplifying. And then, well, I'm actually, okay, so I probably needed one extra step. Sorry, let's go back one here. The negative would distribute. Since I'm kind of running out of room, I'm just going to show that scratch work right underneath. So negative 56 minus 2 plus 8y. And then from here, let's simplify what's in the purple and put that as our final elements. So negative 56 minus 2 would be negative 58. And then plus 8y, well, that doesn't have anything in common, so we'll just leave it out right there as plus 8y. Okay, and then now we can close it down, and that is how we can break this problem down. Okay, so still, I'll write those in as soon as you have them, and then just be extra careful. Okay, so for number 6, let's go ahead and put it right to the side here. So 4 and then b. So be careful of the order. This time it is b that's first. So b is 2, 0, 3x and 1 minus 4y. And if it helps, you can put the parentheses on that multiple termed expression immediately. Okay, and then minus 1/2. And then our a, let's see what a was again. Negative 4, 2, 3. And then negative 7. Okay, so this is what this one looks like now. All right, well, the first multiplication, I am just going to go ahead and multiply it through. So all of these get times by 4. So we would have 4 times 2 is 8. 4 times 0 is 0. 4 times 3x would be 12x. And then this 4 does multiply each of them. So it would be 4 minus 16y. Okay, so there's that setup. Now, this is the other way to deal with a minus and a scalar. So on the first one, I separated them. Here, I am going to go ahead and just say, hey, how about we just do it all in one big step? But when we do that, so I'm using the negative to distribute, which means I would be left with a positive. So the sign is going to change in the front. So remember, when you distribute a negative through, the whole front would become a positive. And so let's break this down. So the two negatives here would become positive. 4 divided by 2 is 2. Here I've got a negative 1/2 times 2. That would be negative 1. Negative 1/2 times 3, well, that would be negative 3/2 as a fraction. Negative 1/2 times negative 7 would be positive 7/2. Okay, so notice the difference here. So on the first one, I kept them separate. Second one, I'm going ahead and doing the negative in the same step. It's just whatever you prefer. And now from here, it's back to addition, where I'd want to make sure I've got, let's go ahead, I think this will give me plenty of room. And I'm just making sure I'm adding corresponding elements now. So 8 plus 2, 0 plus negative 1, 12x plus 2, or no, I was looking at the wrong one, 12x plus negative 3/2. Sorry, so make sure you are doing the right one. So 12x plus negative 3/2. And then 4 minus 16y plus 7/2. Okay, and then this one's kind of nice because there's not really much to distribute. I don't see any distributing that's needed, but we can simplify some of these elements, like 8 plus 2 is 10. 0 plus negative 1 would be negative 1. This is as good as that gets right there, unless you want to change it to a decimal. However, we should change the plus and the negative to just be minus, so 12x minus 3/2. And again, you could change that to 1.5 if you prefer. And then over here, there are the like terms, the constant terms, so the 4 plus 7/2. So we do need to combine those. Scratch work, I'm just going to do some scratch work to the side. They would need to have a common denominator, so it would be 8/2 plus 7/2. So that would become 15/2. And then minus 16y has nothing to combine with, so that's it. Okay, and that's with fractions as those answer parts there. Again, chances are it doesn't matter, and you could have done decimals if you preferred. But that's all I have room for, so I'm going to leave it like that. Okay, and again, you could put these, if you're ever uncertain, you could put these in the parentheses at this point to show, hey, these are the elements, because they are a little close there. We want to make sure we know their separation and that there is 4 unique elements in this problem. Okay, so that's that. So doing addition and subtraction, sometimes along with multiplication of scalars, makes it a little more tedious, but just the multiplication itself, just make sure you're real careful of the signs, and make sure, just visualize it, double check it. Just don't go too fast. Go slow. You got this. All right, so if you do have questions, please let me know. Otherwise, thank you for watching, and I'll see you again soon.